For example 3.4 in your textbook on page 90, we return once again to the bulldozer problem that we discussed in previous chapters. The PMF, recall, we did the last time where we have the number of operating bulldozers after 6 months. We figured out that it was 1/8 for 0 bulldozers at 6 months. 1 bulldozer operational after 6 months had a 3/8 probability. 2 also had a 3/8 probability, and 3 had a 1/8 probability. The question that they're asking for in this problem is, what is the expected value or the mean value of the number of operating bulldozers after 6 months? So we apply our definition of the expectation operator. This is an operator where for the discrete case, we have the summation over all of the x of the individual value and multiply that by the probability that that value occurs. And we sum all of these up. So remember, our notation for the mean value is mu sub x. It's going to be equal to, in this case, the summation of the individual values times the probability of that value coming up. So we have, for 0 bulldozers, we have a probability of 1/8. To that we add 1 bulldozer times a probability of 3/8 plus 2 bulldozers operational times the probability of 3/8, and finally 3 bulldozers operational times the probability of 1/8. We crank this out and it gives us a result of 1.5 bulldozers. Of course, this is not, we can't have half a bulldozer operational, so we can safely say that the mean value or expected value of operational bulldozers after 6 months will be somewhere between 1 or 2 bulldozers. The variance, we have to use our definition of the variance for discrete. We have the variance is equal to the value x sub I minus the mean value or expected value, and we square that and we multiply that times the probability of the value showing up, and then we sum these over all of the x sub i's. But we also had we derived another expression for the variance of x, where it's the expectation operator working on x squared, and we subtract off of that then the mean squared value. So we could do either way. We could say the variance of x is going to be equal to the first value 0 minus the mean, which is 1.5. We square that and then we multiply that times the probability of 1/8, and add to that the second value, which is 1, minus the mean value. We square that and we multiply that times the probability of 1 showing up, which is 3/8. We then add 2 minus 1.5 squared times the probability 3/8, and finally 3 minus 1.5 squared times the probability of 1/8. And when we crank all this out, we see that we get 3/4 or 0.75. Now we could also do this by using, so this solution uses this form of the equation. We could also use the second form of the equation. So we could say that the variance of x is going to be equal to, so here we have the expectation operator applied to x squared. So the expectation operator applied to x squared. For the discrete case, we're going to have the first value of x is 0, so that's going to be 0 squared times the probability that that shows up, 1/8, and we add to that 1 squared times the probability that one shows up, 3/8. We add to that 2 squared times the probability 3/8, and finally 3 squared plus 3 squared times the probability of 1/8. And then we subtract off the mean squared, which is 1.5 squared. And if we were to crank this out, of course, we get the same result. So which form should you use? Either one depends on the problem, which one might be more convenient, which is more intuitive to you to use. It doesn't matter. It's the same result. And finally, the standard deviation is simply going to be the square root of the variance, where we have the square root of 0.75 to give us 0.866. We could also figure out what is the coefficient of variation. Coefficient of variation, remember, is going to be the standard deviation divided by the mean or expected value. So in this case, 0.866 over 1.5, and this gives us 0.577.